The topic of today's presentation is towards automatic application fingerprinting using performance monitoring counters. To start with the basic concept of hardware resource monitoring, we have this microarchitecture. And for each microarchitecture, there is a PMU unit. And this PMU unit is responsible to monitor the utilization of hardware with the help of these PMU events. For each hardware, there is a specific set of events, and these events are actually recorded with the help of some counters, which are hardwired registers on the chip. So whenever an event is occurring, we can record that event on this through these registers. So when an application is coming, an application has a particular resource utilization profile that how it is going to demand and utilize those resources. And obviously there will be events, those will be generated. And these events are actually really useful for the engineers to know that what is happening in their system. If they wanted to improve the quality of service, or if they wanted to know that if something is wrong going on in their system, then this kind of information is really useful for them. But what if we have some kind of change in the architecture, some kind of hardware changes has come, we have upgraded some hardware, then these events will automatically will be changed. So because these are events particular to the hardware, then they are not only dependent to the vendor only, but there are different naming and the nomenclature for the events that is coming with each and every hardware from with a very vast variety of the hardware. So in this situation, when we have hundreds of events, hundreds of different events, and we have only a human mind, that should be able to confront all these changes. Do we think that this is enough knowledge that that we should rely on the expertise of the engineer only? So this is the thing, that the problem we are investigating on, and we can understand this problem with the help of the example first. For example, if we wanted to know that how many L1 data cache was how many times the L1 data cache was accessed. So if we are working on the Intel computer, then the different name is coming. And if we are on the ARM processor, then the name would be changed. Although the event is, and the nature of the event is same, but it is really hard for the engineer to know all these kind of different names which are coming directly from the hardware. So in that case, not only these event names are a problem for the engineer, but there is another limitation for the engineer when we have only a limited number of counters, the registers available to monitor these counters. Having said that, there is another challenge, or there is another problem actually, which is always we have very few number of counters in comparison to the number of events that can be monitored on any platform. So when we have this kind of problem, our engineers, they totally rely on the manual approach, because whatever the architecture they are working on, their solution is limited to that platform only. And while working on, during this manual operation, it is easier to read the numbers, but it is always not that easy to make the statistical analysis by the human mind. So we are highly dependent to the expertise of the engineer only. And even the expert can make the mistakes at that time. And not only the humans, we have some limitations from the machine also, where we have only few counters that we can simultaneously monitor a limited set of events. And above all, these are the platform-dependent solutions that cannot be reused on different platforms. So describing the problem, we have the objective in our mind that how we can help our engineers to monitor the events that are coming from any architecture, so that when this application is using this microarchitecture, what kind of hardware utilization was performed, so that when this application is triggering or using that hardware, then our intelligent solution should be able to fingerprint this application in a nice manner that can reflect that, okay, this is the execution time profile of this application. So we present our solution in two steps. And to outline this solution, we have this profiling and fingerprinting. And as a result of profiling, we will get a fingerprint of the application, which can be used for different purposes. During the profiling phase, our first task was to get the events directly from the platform, so that we know that instead of the pre-selected events or the previous knowledge, we should get the event list directly from the platform. It is not like that the expert has the knowledge and he's just going to monitor those events. The solution should be able to see that which kind of events from this architecture can be monitored. So, but to monitor these events, there are really few counters that can monitor the events simultaneously. And so the second step of the profiling is to compare this outnumber performance monitoring counter to the event and the number of events actually. Once we have this event list and we are able to monitor the possible set of events, then we try to filter out that which are the most relevant events. And it is more logical to, when we have hundreds of events, it is not like the situation that every time each and every event is meaningful. So we try to filter out the most relevant events so that we can rank them from most to least hardware utilization. And this is actually the profile or the fingerprint of that application, that how it is using the resources or the hardware during its execution time. So as a result of profiling, we have this fingerprint that can be used for the quality of service. For instance, if we know that this application is application is highly using L1 caches, then maybe we can install the higher capacity L1 caches. Or if some other application has the same L1 cache demand, or like the similar one, then it means that the both applications, we can schedule those applications on different cores, so that it should not be that there is a L1 contention. Not only the quality of service, we can use this profile fingerprint for the detection purposes. For example, if there is a high rate of page fault rate, it means that something suspicious is going on with this application, and we need to investigate that this application is allowed to run on this platform or not. So once we have this execution profile, this fingerprint can be used into different manners for the different users. Not only this solution, we are trying to improve this solution into a more generalized one, when we can have the same or the generalized approach for the applications who has the short or the long execution time. For example, if we want to monitor more events for a short execution time program, then it is not possible to divide or time slice the execution between different event sets. But if we have the application with a long execution time, then it is obviously really costly to rerun the application to monitor more and more events. So we are working on to get a more generalized approach that can handle different types of applications. Not only the execution time, but we are also considering the applications which has a busy wait loop, so that if the application is with the busy wait loop, there is no ending point for the application, and we need to investigate that what could be an optimal breaking point, that where we should say that this is the hardware utilization from start to end of this application. And then that's all for now. Thank you for listening. If you have questions, you need to unmute.
I have a question, Shamoona. So do you think that this kind of fingerprinting could help in distinguishing malicious versus benign events, such that it could be used for predicting security?
Yeah, there is a good chance that we can distinguish between the malicious or the benign applications, because there are events, those shows that, okay, the access was there. For example, L1 cache 1 access was there. But if there is a higher rate of misses, it means that something was not allowed with this application. For example, a user level application is trying to access the kernel space, then there will be a higher page fault rate. If the page fault rate is something like so high, then it means that the application is trying to break down something, or it is not the usual behavior. Otherwise, if we have this application and resource can be allowed, then there should not be the misses or the branch mispredictions should not be there. There should not be the negative operation events. So if we try to model these events, those reflect that inaccessibility or the barriers or some kind of restrictions, then the model based on these events can distinguish between the applications that, okay, why the legitimate operations were not as many as compared to the operations those are not allowed. So this is the next step, that which kind of malware or the problem is there for the application, but at least this is a good indication that application is trying to do something fishy that is not allowed, that is out of the regular behavior. So we can at least get the behavior of the application that can be extended into more and more specialized approaches.
Thank you very much, Shamoona. Very interesting. Andre, yes, you have raised your hand.
Yeah, sure. I wanted to ask how reliable or accurate are these fingerprints? I mean, if I run the application hundreds of times, what are the variants between the fingerprints generated for this application? Is it possible to, I don't know, use this fingerprint to create some common fingerprint and use it for reliably for detecting the application, or
Actually, what we have done so far, we for getting the events directly from the platform and try to rank them. And the results are really very good, because every time the same event is generated and the number is really very, the fluctuation between these numbers, the sampling is really very low, so that we can rely upon that with some kind of statistic analysis, like moving average or something, that we can remove this noise. But the thing is, the results are really good, that even if we run the application multiple times, then we get almost similar results, because it is going to, when this particular if statement is there, anytime it is going to go for this like branch prediction, and if there is a branch misprediction or not. So the point is that the event behavior is quite static. Then there is, if there is some error, not error actually, if there is some changes in the sampling order, like if we have the sample with 10 millisecond frequency, or if we have the sample with the 5 millisecond frequency, that can be removed with the good statistical analysis. But otherwise, the data that is coming directly from this hardware, this is really very efficient, because this is coming at very low level and with a very good speed. So the rest is just the you can say that applying the right statistical analysis to make them more reliable.
Thank you. And maybe I didn't catch it correctly, but if you want to create fingerprint like this, then may depend on hardware. So if you have the same architecture, but let's say the different version of the CPU with very similar parameters, how, or what is the difference in these fingerprints? You need to create a new fingerprint set, or is it similar to the fingerprint created for other similar CPU type?
This is not the fingerprint that we are reusing from the database only. Whenever the application is coming, we are trying to create the fingerprint from there. That is why we are taking the events directly from the platform, so that it should not be dependent on the pre-selected list, or if the hardware is changed, then this model is not able. So point is, when we are going to monitor all those events, and we will see that which event has been highly generated. Whatever the platform is there for, we don't know the name, but the hardware knows that it happened. So automatically, whatever the name for the L1 cache was there, we will get the values in that event. And when we are going to rank these events, automatically it will come higher, because we don't bother about the names. We just bother about the frequency. So whatever the hardware is there, it will occur. It will occur. That's what we are saying, that instead of knowing the platform, it is something that if we wanted to access to the kernel space, or there must be some kind of barrier that this space is not allowed. Automatically, that event will occur, and we don't bother about the name. So the value automatically reflects that this is something misses something like the mispredictions. So I hope so that
understand.
Obviously, when we will be at that stage, then we don't know that how it will go. But until now, from the initial results and ranking, and this looks like that if we even don't know about the event, the results are coming like very good and in the same pattern. So if we have the reliability of the data, then it means that the solution can be reliable.
Thank you very much.
Thank you.